Lesson 10 is about stationary points, increasing, decreasing, and point of inflection. Suppose I have my y is equal to x cubed minus 3x plus 2. So we know that this is a cubic function, and we can find the derivative of this. So the y prime of that is equal to 3x squared minus 3. Now, what do you mean again by stationary points? Stationary points is the point wherein your y prime is equal to 0. What do you mean by that? Let's try to look at the graph of the function. So as you can see here, the graph is like this, right? So there is a maximum point here, and there is a minimum point over there. And that maximum and minimum point is c negative 1, 4 and 1, 0. Before I told you that the gradient function gives you the gradient or the derivative gives you the gradient function. What's the graph of, or what's the gradient of a horizontal line? The gradient of that horizontal line is actually equal to 0. What does it mean? The tangent at this point C is actually a horizontal line. So let's say, for example, I will draw a tangent there. So basically that's the tangent to that, which is actually y is equal to 4. And here, as you can see, if I'm going to draw a tangent line at that point, so that is a tangent line, alright? So the tangent line at this point C and point D are all horizontal. That's the reason why y prime is equal to 0 in that stationary points. The point C and the point D are called stationary points. They are stationed there, alright? What's the coordinate of those stationary points? So how shall we find those stationary points? To find the stationary point, is what we have said before. To find the stationary point, you need to set your y prime equal to 0. So you have there now y prime, which is equal to 3x squared minus 3 equals 0. It means that 3x squared is equal to 3 and x squared is equal to 1. So x is equal to plus or minus 1. So as you can see here from our answer here, then we have, alright, so in here we can see that the stationary points are really the C and the D, in which the x value is negative 1 and here is 1. Alright, so the stationary point, if we're looking for the x coordinate of the stationary point, so the answer is x equals negative 1 and x equals 1. However, if we're looking for the stationary point or points, then you need to find the values of the x and the y. If that is negative 1, alright, you plug in that negative 1 to your function here, to your function y, then you will get equals to 4. So that is negative 1, 4, when you plug in that minus 1 in this function. And then for 1, alright, for that 1 here, the value of your y there will be 0. Alright, so these are the stationary points. Now, what is that increasing and decreasing functions? I want you to look at the graph. So let's see that we would like to find the interval. We are looking for the interval wherein the function is increasing and decreasing. Alright, increasing. So it is increasing where? When you look at these values, when you look at this graph here, all the numbers, all the behavior of the graph is that for this, it's increasing up to x equals -1. So from the graph itself, it's increasing. Okay, it's increasing from x is less than -1. All right, and then after that, it decreases there, and then increasing again in this region. So the other one is x is greater than 1. In these values of x, it is increasing. What about the decreasing? So the decreasing is actually between -1 and 1. Okay, so if x is greater than -1 but less than 1, then the function is decreasing. Right? Now, let's try to look at, suppose we don't know the graph, we don't know this graph here, and we're just looking for the interval wherein it is increasing and it is decreasing. So as you can see from here, if you're going to draw the tangent in this graph, below before the C and after the D, so the tangent here, let me just draw a tangent. The tangent here is actually will give you a positive gradient because it's leaning towards the right. So the gradient there is positive. Here is also the same thing. The gradient there is also positive. So meaning it's increasing, the dy dx there must be greater than 0. And it's decreasing, the dy dx there must be less than 0. Now suppose we don't know this graph here, so what are we going to do is to just set your y prime is greater than 0. So you have your y prime here. Alright, let's go back to our y prime. We know that the y prime is 3x squared minus 3. Alright, and then what we're looking for is greater than 0 because we're looking for the increasing. So what shall we do is that we already know the x coordinates here. We have 1 and we have x equals -1. So when we draw this one, the real number line, or when we sketch that one, you need to look at your -1. You need to look at your 1. And as you can see, it opens upward because the number before x squared is positive. So it opens upward like that. Okay, so greater than 0 are the areas wherein it's above the x, because in this line, the x there is equal to, or in this line here, the y prime is equal to 0. Alright, well, this portion there, the y prime is greater than 0. Well, below the line, the y prime is less than 0. So as you can see from here, if x is less than -1, if x is less than -1, it's increasing. And if x is greater than 1, it's also increasing. So either this or this, they are both increasing in that region. And then between these two, x is greater than -1 but less than 1, it is decreasing because it's below this line here. Now, for us to be able to get a clearer view of this situation, let's try to make a table of like an interval. Okay, so I will make an interval just for us to analyze it further. So this is my values of x. This is the behavior of the function. I would say the behavior of the graph of the function. And this is the dy dx. Okay. And then we know our base from our answer a while ago. We have -1 and 1. So let's have for x is equal to -1, for x is equal to 1. Alright. Then we need to get the numbers if x is less than -1. So here x is less than -1, then here x equals 1, then here x is between -1 but less than 1, then here x is greater than 1. Please don't get confused yourself about this. It's just like this one, that if you have 2 points here that divides this line -1 to 1, this portion, for us to be able to analyze what's going on to the graph, we need to look at the behavior of the function for the real numbers. So we need to look at these values here, which is x is less than -1, which is that one, and x is equal to -1 at that instant, and then x is between -1 but less than 1 at this instant, and x equals 1, and x is greater than 1. Sorry, this video is a limit because this is only a free version, so I will just do it as quick as I can. So as you can see from the graph, let me just remove these lines here. As you can see from the graph, the behavior of the function at x equals -1 or before -1 is increasing. It's increasing there. And this one here is greater than 0, all right, or positive, or we can say that it's positive. And then if x equals -1, it's stationary. It's stationary. It's very obvious there is point C. And we're in here, the gradient is equal to 0. And then between these two, it's decreasing. On the graph, it's decreasing. And then here, the derivative there is less than 0. And then if x is greater than 1, sorry, I forgot, I'll put here x equals 1, and x is greater than 1. If x is equal to 1, then you have there, this is stationary, that's stationary, and the gradient there is equal to 0, and then this one is increasing based from your graph, and the gradient here is greater than 0. In short, you need to look at that if the dy dx is positive, then the function is increasing. If the dy dx is negative, then the function is decreasing. If the dy dx equals 0, then it is stationary at that point. I'll give you a second example of this one on the next video. Thank you.